Hello TAMS users. In the last couple of videos we were looking at how to analyze, count, locate records that overlap in your data. Now we're going to look at records that co-occur. Co-occur is similar to overlap, but the records don't actually have to touch. Instead, they have to share a common context variable value. We're going to use our literature and science project. Now there are no co-occurrence reports that you can access from your workbench. You must have a results window, and the best results window to work with most things is a simple unlimited results window, and that's what I have just generated here. Like I said, co-occurrence refers to an analysis of some value that shares some other value. So in a sense, they're not overlapping, but they coexist in some part of your document or in some sort of theoretical space. I could look, for example, at codes that are grouped by gender, that kind of thing. So we'll get to some of that in more detail when we come to looking at how to analyze context variables in relationship to data variables. Data variables are the ones listed in the code column. Context variables are these other columns generated in your searches. But right now we're still focused on context-to-context relationships, and there are two reports here. This report, the co-occurrence table, was a custom report done for a TAMS user many years ago. It's pretty arcane and difficult to use. After playing with it for a while, I realized that I could make a simpler version of the choices and a clearer version of the choices, and that's what this graph chart co-occurrences are. Now, to start with, what I want to do is not use all of my data. I want to use a subset. So just to review, TAMS results windows have both a front stage and a back stage. There are certain rows that you can see, but there may be a lot more rows that you can't see. And to figure out what you are seeing, you look at this fraction up here. This says I have 176 rows total, and I'm looking at 176 of them here. If I look at narrative, okay, I can see that there are 8 visible, and that's confirmed by this number 8. Mind you, those don't update in the outline view. Those just represent the table view. I have 8, and those 176 are still around. They're just backstage and are available to come on stage depending on what I do here in my results window. So I've got my 8 records here, and what I want to do is find out which ones overlap in the time codes listed here. So I'm going to see which ones are close to this narrative code. Which one is in the same time code as that narrative? So I come here to my graph chart co-occurrences, and I have a bunch of choices. First of all, do I want things to be forced into the same file? Yes, I don't want, if there's a 128 in one file and a 128 in another file, I don't want those 128s to be treated the same. Keep the files separate. The next list says, all right, so what are these things that these records should share? Well, for me, I want the things that share time. Well, what am I interested in looking at that shares time? Well, I'm interested in looking at the codes. I could use a code set, the current selection only, or all records. Now, we'll use all records, and that's typically what you want. This refers to graphs. We're going to come back to this in just 1 second because it provides some additional very useful information. Let's just run the table to start with. All right. So what this tells me and it's very important to understand what this means, is that one time code has both capacity and narrative. Two different time codes have example and narrative. 5 different time codes have example, negative, and narrative, and so forth. Let me be clear. There could be in one of those time codes multiple uses of the code narrative and multiple uses of example negative, but it only counts once here. This is the number of time codes, that first variable we picked, that include both of those. However many times either of example negative or narrative appear. So there may be multiple example negatives and narratives, but in 5 time codes, they are found together. All right, which 5? We don't know. That's what that additional includes group does. So this is how to read those numbers. You said you wanted time. Well, that's how many times those code variables that you picked here co-occur. Let's run the table again now that I've said include the groups. These are the groups, so we should get some time data here. All right, so here it gives me some additional information. So, for example, here's our lovely example negative, which co-occurs with narrative 5 times. Where are those 5 times? Well, at 128 in Amy's file, 659 in Amy's file, 153 in Xander's file, 632 in Erica's file, and 820 in Erica's file. So again, there may be in 128 in Amy, there may be many occurrences of narrative and example negative, but there are 5 total time codes that they co-occur in. So by checking that box, we can kind of locate where things are, and we have a nice total column there that there are 22 co-occurring time codes with narrative in these codes. All right. Obviously, things can get very messy if we use all of the data. So here's all of our data. And now we're going to do that same report, graph, chart, co-occurrences. Yes, we're going to group on time again, and we're going to look at code again, and we're going to include groups. Eventually, we're going to use a variable weight line, but we're going to start with a table. This takes a long time to build. There is a lot of work going on. Not only are there loops within loops, but lots of memory allocation to keep track of everything and make sure that we're not doing redundancies. And so it takes a while. Give it time, and this is a small project. We're going to have to find a faster algorithm, but we don't have one right now. Getting the right answer is more important than speed and memory, unfortunately. So there is a faster way to get this data, and I will show you that next. But here is our giant table, which goes on forever in both directions. We can see the intersection we've been kind of watching of the 5 co-occurrences of example negative and narrative. And because this includes both codes in both directions, somewhere down here there's narrative and a column called example negative, and those should match, and they do. There are also huge patches of noise here where there's just a lot of stuff taking up room, but we're not really interested in the zeros in most cases. So just like with co-coding table from the workbench, doing a graph gets rid of that noise. So let's take a look at that graph, and again it is going to rebuild that table, which takes time, and then turn it into a graph. So here is it's working away. And like I said, there is a faster way to do this, and that's using select near. Select near will involve 2 steps, but it basically creates the data necessary to do this in a much more efficient way. So, slowly building the graph, and it will be highly messy, but what it won't have is all the zeros. So you can see here in this graph, it's a complete messy, squiggly, chaotic thing. Sometimes things co-occur with themselves here. You can see some things are more heavily co-occurring, some things are more lightly co-occurring. Oh, look at this heavy black line to narrative. There are our 5 cases here, and they're connected to this line. This information gives you how many and where to find those co-occurrences. So useful data, interesting data. It's fun just to spend time when you have something this complicated, kind of drifting around and seeing where the significant connections are. Again, this is co-occurrence, not overlapping codes, though in this case, from how we have defined co-occurrence, that would include overlapping codes, and in most cases it would. So this is a superset of the early analysis that we've done. All right, so there's an interesting 3 between priorities, literature, and relevance. So these are things that are near each other, but not necessarily overlapping. So that's the first way, and a great way to get some co-occurrence data. The second way is using select near. And our first attempt at select near is going to actually recreate exactly the results we got. Here's select near, and like last time, we're going to start with a simpler set to study the results. We'll do our narratives, and we want to select near. Here it is on the shelf. Select near is very complicated. It takes the current selection and it matches it with records that could be from a results set, the selected records, or something else. We're going to use all records, which means it's going to ignore that. We want things in the same file only. For our first run through, we're going to ignore this near definition of near. We're going to use a very exact definition of near in which something has to match a string value, meaning a text value, something else, and that thing is time. So this is basically like the group. And basically, this is set up to use codes almost exclusively. So it doesn't even matter about codes because we're just looking for whole records that match when time is equal to this string. Okay, we can make this equal if we're concerned about it being equal, but it shouldn't make any difference. There we go. We now have all the overlapping records for those. All right. And you can see they share all the same time, these records. So let's, we can paw through these, open and close these triangles. Again, we're in outline view. We have the disclosure triangles, which means we're thinking about level 1s and level 2s. And let's get that report we discussed in a previous movie, the graph of hierarchical data. So we want to check codes with codes, though I kind of want to know where those codes are. Actually, we're going to make a table of this, and we want everything grouped together, and we want everything counted. So we want codes with codes, and let's break it apart by file name and just see what that gives us. All right. So here we have narrative, and you can see it's all broken down here by person and code. I'm going to get rid of that and just see if I can find my example negatives. There are my 5 example negatives. Voila. Now, I'd like to know where those 5 example negatives are. Like I said, this can get very redundant with what we just saw, and you can see that it's faster. I want time, but I want time to be after code. So I'm going to drag it down there. I'm going to select code and time and generate the report. That means that it's going to sort on the codes, because that's the first thing. These are all overlapping with narrative. Here we have a bunch of narratives. Oh, you know what? We need people in there as well. So let me throw in people into the mix. I'll just throw that in as doc, generate that report. So now I can see where my example negatives are. 1, 2, 3, 4, and 5. True, it's not going to give us a sum, not at least as we have it set up here, but I do get redundant data with what we got before. That's the first use of select near. We're going to use a much more complicated example of select near in the next video, which allows us to expand the data that we are comparing and contrasting. So hopefully this helps you get even a broader view of how your data codes interact with each other, and we will continue working on this problem in the next video when we finish up data code comparisons with additional uses of select near.